Hello everyone, and welcome back to the last video lecture, which is going to be on graphing linear inequalities. So a linear inequality in two variables is any inequality that can be written in the form ax plus by is some inequality symbol c, where a, b, and c are real numbers and a and b are not both equal to 0. So this inequality symbol right here doesn't have to be a less than. It can be either a less than, greater than, less than or equal to, or greater than or equal to. So linear inequalities, as you guys saw when we solved linear inequalities, has an infinite number of solutions. So the solution to an inequality in two variables is any ordered pair x comma y where when the numbers are substituted in for x and y, they satisfy the inequality. Meaning that when you plug your point in for x and y respectively, you will get a true statement after you simplify. And if you remember from linear inequalities back in section 9.1 through 9.3, inequalities have an infinite number of solutions in one variable, so they do in two variables as well. So we are going to be testing solutions all the time in this section. So when you test a solution, you're going to take an ordered pair which has an x-coordinate and a y-coordinate. And when you are determining if it is a solution to an inequality, you are going to plug the x-coordinate in for where you see an x and the y-coordinate in for where you see a y. You're going to simplify and see what happens. So we're going to test to see if the ordered pair 2, 5 is a solution to the inequality y is greater than or equal to x plus 1. So 2 is the x-coordinate and 5 is the y-coordinate. So I'm going to take 2 and 5 and I'm going to plug them into their appropriate variables in this inequality. I'm going to simplify and I'm going to see if a true statement results. So I'm going to plug 5, the y-coordinate, in for y, so I have 5. Leave the greater than or equal to where it is. In place of x, I'm going to plug in 2 plus 1. There's not much to simplify, so 2 plus 1 is 3. And I get this statement. 5 is greater than or equal to 3. So 5 is greater than or equal to 3. It's obviously not equal to, but it's an or. So since 5 is greater than 3, this is a true statement. Since this is a true statement, yes, this ordered pair is a solution to this inequality. Now keep in mind that this ordered pair is not the only solution to this inequality. There are an infinite number of ordered pairs, but this is just one of them. So when you are graphing inequalities in two variables, remember that the solution to an inequality is any ordered pair that satisfies the inequality. Now there are an infinite number of points that can satisfy any inequality, and not all of them are actually on the line. So there are going to be plenty of points in the coordinate grid that are not on that line that are solutions to that inequality, and they do need to be represented as solutions. So the only way that you can visually represent all of the solutions to the inequality that are not on that line is to draw a boundary line and to shade the part of the coordinate plane that contains the points that also satisfy the inequality. So basically half of that coordinate grid is going to be a solution, and the half is going to be determined by that boundary line, and you're either going to shade above the boundary line or below the boundary line. Shading is the only way to indicate that all of these points in this entire region over here are also solutions to this inequality, not just the ones that are on the line. Now, the only way to figure out where you're supposed to shade exactly is to use test points. You're going to pick a test point and use this process over here to figure out if it is a solution to the inequality. If it is, you would include the part of the coordinate grid that includes that test point. If it's not, you don't include the part of the coordinate grid that contains that test point. So here is the process of graphing a linear inequality in two variables. So what you're going to do is you're going to graph the inequality as if it was a regular line. Meaning you really want y by itself. If y is already by itself, it's in slope-intercept form, and you can graph it using the process for slope-intercept form that we covered back in section 7.3. Now, even though the overall process of graphing with slope and y-intercept is going to be the same, it's going to be a little bit different in inequalities. So you are going to draw a solid line if the inequality contains either a less than or equal to or a greater than or equal to. The reason is because of the or equal to part, you would include all of the points that are on the boundary line, so you would indicate that you are including all of the points that are on the boundary line by drawing a solid line. Now, if your inequality contains either just less than or just greater than, you're going to make a dotted line or a dashed line. So what a dashed or dotted line indicates is that you are not including the points that are on the line itself. The points that are on the line itself do not actually satisfy the inequality because it's just less than or just greater than. However, since you do need a boundary line to indicate visually where the shading stops, you draw it there, but you draw it dotted to indicate that these points are not actually part of the solutions. Then, once you have graphed your line, you are going to pick a test point that is not on the line. I cannot emphasize that enough. Do not pick a point that is on the line. It doesn't actually help you. Pick any other point that is not on the line. Now, if the graph does not go through the origin 0, 0, using 0, 0 as a test point is incredibly easy to do because it's the origin. 0 is a really easy number to work with, and it's great. However, if the graph does go through the origin, pick a different point. So just pick a point that is not on the line. Then you are going to substitute the x and the y coordinates of your test point in for x and y in the inequality. And you're going to simplify using order of operations, kind of like we did back here. Now, if you get a true statement, that means that point is a solution to that inequality, so you're going to shade toward the test point. If you get a false statement, that means the point was not a solution to the inequality, so you're going to shade away from the test point. Toward and away means if it's a true statement, you're going to shade on the side of the line that's toward the test point. If it is a false statement, you're going to shade on the opposite side of the line away from the test point. So we're going to take this inequality and we are going to graph it. So the first thing I'm going to do is I'm going to start as if this was a regular line. Y is by itself, which is fantastic. That means that this is in slope-intercept form, which means that the number next to x is your slope, and the number with no variable is your y-intercept. So your slope is 2 over 1, which means that we are going to be going up 2 and to the right 1. Your y-intercept is going to be 0, b. And since b is -1, your y-intercept is going to be 0, -1. So I'm going to start as if this was a normal line. I'm going to draw my y-intercept. And then to get my second point, I'm going to count up 2 units and to the right 1 unit. Do not draw another point until you have gone both right and up. So I'm going to go up 2 and over 1. And I'm just going to do another point up 2 and over 1. Now, I'm not going to draw anything yet. Because this is an inequality, it does matter if you draw a dotted line or a solid line. So you're going to make a solid line if the inequality contains a less than or equal to or a greater than or equal to. This right here is a less than or equal to, which means I am going to draw a solid line. Next, I'm going to pick a test point that is not on the line. So a test point, it goes close to the origin, but it doesn't actually go through the origin. So I'm going to go ahead and test the origin 0, 0. And what I'm going to do is I am going to substitute my x and my y coordinates of my test point in for x and y in the inequality and see what happens. So I'm going to take my y coordinate 0 and plug it in for y. So I have 0 less than or equal to 2 times the x coordinate of the point I chose, which is 0, minus 1. And here's why 0 is really easy to work with. 2 times 0 is 0. 0 minus 1 is negative 1. Now, 0 is not less than negative 1. 0 is greater than any negative number. So this is a false statement. Because that is a false statement, we are going to shade away from the test point. Now, the test point was here, which is above the line, so I'm going to shade on the opposite side of the line that does not include the origin. So you're going to shade away from the origin. So this entire section, part of the coordinate grid over there, all of those points that I shaded, those are all solutions to that inequality. On your homework, you're going to be drawing much nicer graphs. This is as good as I can do by hand. So if you want to try this one before I go over it, feel free to pause the video right now and resume it when you are done working. So for this next one, we are going to start by pretending that this is a regular line, and we are going to graph it as if it is a regular line. Now, since y is by itself, that means this is in slope-intercept form already, which means the number next to x is your slope. So your slope is 1, and the number with no variable is your y-intercept b. So your slope is the whole number 1, which I'm going to turn into a fraction by putting over 1. And your y-intercept is going to be 0, comma b. Since b is positive 2, your y-intercept is 0, comma 2. So you're going to start by graphing the y-intercept 0, comma 2, which is right there. And then to get your second point, since this is a positive 1, we are going to be moving up 1 and to the right 1. So I'm going to go up 1, right 1, up 1, right 1. Now, as far as whether you draw a solid line or a dotted line, remember, if your inequality contains one of the or equal to's, it's a solid line. So since this is a greater than or equal to, I am going to draw a solid line. Next, I'm going to pick a test point that is not on this line. Again, any point anywhere that is not on the line is fair game for a test point. I'm going to go ahead and choose the origin because I'm lazy and I like numbers that are easy to work with. So I am going to take the x coordinate 0 and I'm going to plug it in for x, and the y coordinate 0 and plug it in for y, and I'm going to simplify and see what happens. So y, which is 0, greater than or equal to x, which is 0 plus 2. 0 plus 2 is 2, and we get 0 is greater than or equal to 2. Last time I checked, 0 is not greater than 2, so this is a false statement. Because this is a false statement, that means 0, 0 did not work. So since 0, 0 was down here below the line, I am going to shade on the opposite side of the line away from the origin. So I'm going to shade all of this above the line. So for this next one, we're going to start by graphing this as if it was a regular line. So let's check, is y by itself? Yes, y is by itself, thank goodness. Because y is by itself, that means this is in slope-intercept form. So that means that the number next to x is your slope, and the number with no variable is your y-intercept. So your slope m is going to be 1/2. Your y-intercept is going to be 0, comma b. b is the number with no variable, so your y-intercept is 0, comma 3. So you're going to start by graphing your y-intercept 0, comma 3. Then to get your second point, you're going to use the slope. So since this is a positive 1/2, we are going to be moving up 1 and keep the run to the right 2. So you're going to go from your y-intercept, you're going to count up 1 and to the right 2. So up 1 and right 1, 2. So up 1 and to the right 1, 2. Now, before you draw anything, make sure that you are drawing a solid or dotted line as appropriate. This is a less than or equal to. Since this is a less than or equal to, we're going to draw a solid line, which indicates that all of the points that are on the line itself are also solutions to the inequality. Next, we need to figure out where to shade, so we're going to pick a test point, any test point that is not on the line. I'm going to pick this one, which is 0, 0. It doesn't go through the origin, so you can go ahead and use it. As long as the test point is not on the line, you can use anything. You could use this one for all I care. So I'm going to plug the x-coordinate of the point I chose in for x, the y-coordinate of the point I chose in for y, and see what happens. So I have 0 is less than or equal to 1/2 times 0 plus 3. So 1/2 times 0 is 0. 0 plus 3 is 3. So is 0 less than or equal to 3? 0 is less than 3, so this is a true statement. So since we got a true statement, that means our test point, the origin, is a solution to the inequality. That also means that any point that is on this entire half of the coordinate grid with the origin is also a solution to the inequality. You could have chose 1, 1 and gotten the same result. So I am going to shade on the same side of the line that includes my test point. So I am going to shade toward my test point, all of this over here. So for this next one, we're going to check to see if the equation is in slope-intercept form. Since y is by itself, this is in slope-intercept form, which is good. That means the number next to x is the slope, and the number with no variable is your y-intercept. So your slope is going to be 4. Turn it into a fraction by putting it over 1. Your y-intercept is going to be 0, b. b is -5 because a number always takes a sign to its left, so your y-intercept is 0, -5. So I'm going to start by plotting 0, -5, which is way down here. And then to get my second point, I'm going to use my slope. Now, since this is a positive 4, we're going to count up 4 units and to the right 1 unit. So I'm going to count up 1, 2, 3, 4 and over 1. Then I'm going to count up 1, 2, 3, 4 and over 1. Now, as far as what kind of line to draw, we need to look back at the inequality. This is a greater than or equal to. So since this is an or equal to, I'm going to draw a solid line. Now that I've drawn the line, I need to figure out where to shade. So I'm going to pick a test point that is not on this line. Since it does not go through 0, 0, I'm going to be lazy and use 0, 0. So I'm going to pick the x-coordinate of the point I chose, and I'm going to plug it in for x. I'm going to take the y-coordinate of the point I chose and plug it in for y. So I'm going to have y, which is 0, greater than or equal to 4 times 0 minus 5. So 4 times 0 is 0. 0 minus 5 is -5. So is 0 greater than or equal to -5? Well, 0 is greater than any negative number, so yes, 0 is greater than or equal to -5. This is a true statement. So since it is a true statement, I am going to shade on the side of the line that is on the same side as the origin. So the origin is over here. My test point is over here on above the line, so I am going to shade the entire coordinate grid above the line. You get the point. It looks something like that. Now for this next one, remember when you are graphing an inequality, you're going to graph it as if it was a regular line to start. So you're going to check, is this in slope-intercept form? And no, you see how x and y are on the same side of the inequality sign? This is actually in standard form. Remember, in order to graph using slope and y-intercept like we've done in the last few examples, y needs to be by itself. So you have to get y by itself first. So I'm going to get rid of this minus 2x by adding 2x to both sides. So I get y leave the less than symbol where it is, and then, yes, you can write it as 4 plus 2x, but you really want to try and stay consistent to the y equals mx plus b format. So I'm going to put that positive 2x first. And since that 4 was also positive, I'm going to separate them with the plus sign. So y is less than 2x plus 4. Now, we didn't need to divide by anything. Y is already by itself, so that was all we needed to do for that. So now that y is by itself, this is now in slope-intercept form, which means the number next to x is your slope, and the number with no variable is your y-intercept. So your slope is going to be 2. Turn it into a fraction by putting it over 1. The y-intercept is going to be 0, comma b. b is positive 4, so your y-intercept is 0, comma 4. So I'm going to start by plotting my y-intercept. To get my other point, I am going to use the slope. Since this is a positive 2, I am going to be moving up 2 and to the right 1. So I'm going to count up 1, 2, to the right 1, up 2, and to the right 1. Now, do not draw any lines yet, because you need to look at the symbol that is in the inequality. The inequality contains a less than. Not a less than or equal to, it just has less than. Because this is just a less than, we are not going to be including the actual points that are on the line. So instead of drawing a solid line, we are going to draw a dotted line. It's as good as I can draw. We're going to draw a dotted line because the inequality contains just less than. So what that means is that this line is more of a boundary marker, and we're not actually including the points that are on the line itself. So now that we have got this line graphed, we're going to figure out where we are supposed to shade. So you're going to pick a test point that is not on this line. 0, 0 is a good one to choose since it does not go through 0, 0. Just pick a point. You're going to plug the x-coordinate of the point you chose into the x variable in the inequality, and you're going to plug in the y-coordinate of the point you chose in for y. You might as well use the one where y is by itself. So I have y, which is 0, is less than 2 times 0 plus 4. 2 times 0 is 0. 0 plus 4 is 4. So is 0 less than 4? Yes, 0 is less than 4. So because 0 is less than 4, that means this is a true statement. Because we got a true statement, that means our test point is a solution to the inequality. The test point was below the line, so I'm going to shade on the same side of the line as the test point, so I am going to shade below the line. Now for horizontal and vertical lines, they are going to be pretty straightforward. So we're going to graph x is less than 0. Remember, if there is no y at all, if y is totally missing and all you have is x and some number, this is a vertical line. Since this is a vertical line, x equals 0 is right here. Now, you do need to pay attention to the type of inequality symbol. This is just a less than. So because it's just less than, this is going to be a dotted line. So I'm going to draw a dotted line here at the y-axis, which is x equals 0. Now, since this is x is less than 0, we are going to shade the side of the coordinate grid that contains all of the points that have x coordinates less than 0. So all of these points over here, these are all x coordinates that are less than 0. So I'm going to shade on this entire side of the coordinate grid. All of those points on that whole left half of the coordinate grid all have x coordinates that are less than 0. Now for this next one, y is greater than 4, remember if all you have is a y and x is just missing entirely, this is a horizontal line. This is a horizontal line at 4, and since this is just a greater than, not a greater than or equal to, it's just greater than, that means we're not going to include the points on the line, which means that this is going to be a dotted line. So because it's going to be a dotted line, I am going to draw a dotted line here at 4, a dotted horizontal line at y equals 4. It's as good as I can draw. And then for where to shade, you are going to shade the side of the line that contains points that have a y-coordinate that is greater than 4. So all of these points up here all have y-coordinates that are greater than 4. So I'm going to shade above the line. That means all of these points on this entire section of the coordinate grid all have y-coordinates that are greater than 4. Alrighty, and for this last one's going to actually be a little bit trickier. We're going to graph x minus 3y is less than or equal to negative 9. Now, y is obviously not by itself. Since y is not by itself and x and y are on the same side, this is in standard form. So, before we even touch the graph, we need to get y by itself first. So since we need to get y by itself first, I'm going to start by getting rid of this x. Now there's nothing to the left of that x, which means it's positive. So I'm going to move it to the other side by subtracting it from both sides. So we get negative 3y is less than or equal to. You really need to write this so that the x is first. And remember, there is a hidden 1 there. So negative 1x minus 9. Then I'm going to finish getting y by itself by dividing, and we are going to be dividing every single term on both sides by negative 3. Now here's the thing. We have just divided by a negative number. We just divided both sides of an inequality by a negative number. You might remember from from when we last did these that if you divide both sides by a negative number, you must flip the inequality symbol. So I'm going to have to flip that inequality symbol to become a greater than or equal to. Let's try that again. I'm going to flip that inequality symbol to become a greater than or equal to. Then negative 1 divided by negative 3 is positive 1 over 3x. And remember, you need to leave it as a fraction. Don't give me a decimal. That makes it worse. And then negative 9 divided by negative 3 is plus 3. So now that y is by itself, now this is in slope-intercept form. So that means your slope is the number next to x. So your slope is 1/3. And your y-intercept is 0, 3. So you're going to start with your y-intercept, 0, 3. To get the second point, we are going to count up 1 unit, and we are going to count to the right 3 units. So we're going to count up 1 and to the right 1, 2, 3. Count up 1 and to the right 1, 2, 3. Now for whether this is a solid line or a dotted line, it doesn't really matter. When you turn around, when you flip an inequality symbol, that doesn't change whether it's solid or dotted. This entire time it was some sort of or equal to. So since this is a greater than or equal to, I'm going to draw a solid line. Now the flipping of the inequality symbol does change where you need to shade. So we are going to test any point that is not on this line. So I'm just going to select that point right there, 0, 0. And I'm going to test to see whether this is a solution to my inequality. And I'm going to go from here where y is by itself after I flip the inequality symbol. So I'm going to plug the y-coordinate of the point I chose in for y. I'm going to plug the x-coordinate of the point I chose in for x and simplify and see what happens. So y, which is 0, is less than or equal to 1/3 times 0 plus 3. So 1/3 times 0 is 0, 0 plus 3 is 3. And 0 is not greater than or equal to 3. So since we have a false statement, that means that 0, 0, the origin, is not a solution to this inequality. So I am going to shade on the side of the line that is away from the origin. So I'm going to shade this half of the coordinate grid above the line. So that is it for section 9.4, and that is actually going to be it for the video lectures for this course. So thank you all very much for watching this video, and thank you all so much for watching the video lectures. It is wonderful to see that you guys have been watching them and have been, they have been valuable to you. They did take a lot of time and work, and so thank you so much for watching them, and I hope that these were valuable resources for you. If you have any questions on either this or anything else in these video lectures or in the course, please don't hesitate to email me, and I hope that you all have a wonderful summer, and thank you all so much for watching, and I will see you later.